In this tutorial and in the next few coming up, we will learn about how to calculate the area of various quadrilateral shapes, okay? One thumb rule you should always keep in mind is that whenever you are given any shape and you are supposed to calculate the area, if you don't remember the general formula, just break down that complex shape into its individual components and then calculate the area from there on. And we will basically follow the same method to calculate the area of this shape, which is a trapezium in this case, okay? Now, our task with respect to the shape given is develop a general formula for the area of a trapezium and then use it to find the area with the given dimensions. Alright, now this trapezium ABCD, we have the top dimension as 4 centimeter and the base dimension as 6 centimeter. These are the sides that are parallel to each other, okay? Now, we are not given either this dimension, the dimension of the non-parallel sides, alright? But we are given the height between these two parallel sides. Alright, so first let us develop the formula in general. So the very first thing I'll do is I'll start assigning some names to each line segment. So line segment BC is called A and A is equal to 6 centimeter. Likewise, line segment AD is equal to B. So B is 4 centimeter. And we already have the height between these two lines. So H is 3 centimeter. You can see that I can divide this trapezium into three parts. The part 1 is this shaded part. Let's label this as part 1. Then we have a rectangle in between. Let's call it as area number 2. And then you have another part. Let's say this is the area number 3. So these are my three areas. Alright. Now what do you see as the formula for area 1? Area 1 is a triangle, right? With a height h. And let's say this dimension is x1 units. Alright. Now you have the base and you have the height for a triangle. So as simple as it is, area 1 is equal to 1/2 times x1, the base, times the height, right? And likewise, you can say that my area 3 will be also similar because it's also a triangle, right? So area 3 could be, if this is my base, let's say this dimension is x2. So area 3 is going to be 1/2 times x2 times height, because these two heights are the same, right? Okay, so now all that remains is area number 2, that is the middle portion, and it is a rectangle basically, right? With the height h and the dimension b on the top side, right? This is my rectangle, right? So the area 2 is equal to b times h. In that case, what will be the total area of this trapezium? Now, with respect to this diagram given, I have the individual areas of each one of the parts of this trapezium. That means all I have to do is the area of a trapezium, let's say it is T, is equal to area 1 plus area 2 plus area 3. Once you have that, you can find the total area, right? That's why we were breaking this down into three parts. And let's put those expressions back into this summation form so that you can calculate this area. So this will be 1/2 x1h plus 1/2 x2h plus bh, right? This is area 1, area 3 and area 2. Okay, now let's take the common parts out and see what remains inside the parentheses. I am applying the reverse distribution principle. So 1/2 times h, it can be taken out. What remains inside is x1 plus x2 plus twice of b, because I have taken the 1/2 out, right? And there is only b and h. If I simply multiply this thing with 2 and divide with 2, I do not change this term at all. It still remains balanced, and I can take my 1/2 out, and what remains inside is 2 and b, right? So this is my new expression. Let's make it a little bit simpler by simply rewriting this whole thing and say x1 plus x2 and b. I'll rewrite it twice, something like this. 2b is broken down into two parts. Now you see, the reason I'm doing it this way is this dimension, the dimension BC, which is the dimension A stated here, it is equal to x1 plus x2 plus this middle part b here, right? So A is a sum of x1, x2 and b. So that means I can simply replace this whole thing, the one which is inside the parenthesis, as x1 and x2 and b can be replaced by one single dimension as A. and B remains as it is. So this is my formulation for the calculation of area of a trapezium. Now you have all the dimensions and you can simply plug in those dimensions and calculate the area, right? So let's do that. So my computed area for this shape will be 1/2 times h is 3 centimeters times dimension A is equal to 6 centimeter and dimension B is 4 centimeter. So 1/2 times 3 times 10, 2 cancels 10, it becomes 5 and it is 15 centimeter square. So the key point here for you to pay attention is number 1, break down a complex shape into its individual components. That's what we did. So we found some simpler shapes. We found triangle and a rectangle and a triangle. Then we summed up the area, which was the key point, and then you obtained a very general form of finding the area of a trapezium right here. Okay. Now let us pause here and discuss about finding the area or a general form of an area of a parallelogram in our next tutorial.